Hi, yeah, I've never seen myself on a screen, so I keep looking at it, sorry. But yeah, I'm Carolyn. I'm a front-end developer based in Berlin, Germany, but previously I was a technical writer and also a journalist. So this topic of inclusive writing, I've been in and around it for a while now. And looking at this slide, I know what some of you might be thinking. What the heck is A11y, A11y, or whatever I'm seeing on the screen right now? And this is pronounced as Ali, and you might be familiar with it if you've used I18N before, because they're both alphanumeric acronyms. This means that the letters between the first and the last have been replaced by a number representing the number of missing letters. And this A11y format is used popularly across the web to talk about accessibility. It's a hashtag on Twitter, it's a category on the Practical Dev, and is also a community-driven initiative called the Ali Project, whose goal is to help web developers make their websites and applications more accessible. And now that acronyms are out of the way, let's talk about what accessibility actually is. So Laura Kalbag outlines this really well in her book, Accessibility for Everyone. She defines accessibility in the physical world as the degree to which an environment is usable by as many people as possible. And web accessibility is the degree to which websites are usable by as many people as possible. We can think of both kinds of accessibility as forms of inclusion. And this concept of inclusion has been finding its stride in the web development community, and it's not really that difficult to figure out why. According to the World Health Organization, there are over 1 billion people globally who need an assistive device. And with statistics like these, organizations and open source projects alike realize that they could be unintentionally locking people out of their projects and their products. And accessibility can play a huge role in enhancing people's experiences online. But in order to have our products actually be useful, we need to start understanding that people access the web very differently. Assistive technology is one of those ways. One of the most talked about forms of assistive technology is the screen reader. So this software takes in the information that's on the screen and turns out a kind of Siri-like voice output, audio signals, or even Braille. This is a project that I'm working on with another Berlin-based developer, Sarah Vieira. There aren't that many components, as you can see, a search bar, heading, text, some links. But let's see how a screen reader would consume this page.
Link. https://so-u-1-2-learn-graph-ql.now.sh/ search edit text. Heading level 1, waving hand, hello. Heading level 2, so you want to learn GraphQL? Learning new tech we know, so we are here to help you. First question, do you know what GraphQL is? Visited link, yes. Visited link, no. Voiceover off.
So besides being great for catching typos, if you noticed that, the screen reader has now made this web page accessible for those who have visual impairments. Another common form of assistive technology is keyboard navigation. And this is when a person uses only a keyboard to access a computer or website. Screen readers are often, but not always, paired with keyboard navigation. So Shopify's developer portal is a great example of this because it is fully keyboard accessible. And our focus as a user follows the visual flow of the page. And while this talk that we're doing today is going to focus mostly on screen readers and keyboards, accessibility on the web isn't just limited to that. People have varying needs, and so we've created a diverse range of tools to match those needs. This includes navigation hardware, which is similar to a hand-operated mouse, but maybe operated by your mouth or foot. Or switch inputs. With switch inputs, the software moves throughout the options on the page, and people can trigger the switch when their desired option is highlighted. Or there are trackers, which rely on a camera to analyze the movement of a user's eyes or head to navigate the screen or take action on the page. All of these technologies can help a wider range of humans engage with and on the web. But they can only help people to a certain extent. We need to think about how we program our websites and make sure that we're trying to optimize for others' success. But I understand that this is a lot easier said than done. Starting off can be really intimidating, and this is because it feels like there are just so many considerations to make a fully accessible website. And that's a fair assumption, especially considering disabilities and impairments are multi-level and spread across a spectrum. There are also many misconceptions when it comes to accessibility on the web and what that really means. So in a post on the ALLY project, Dave Rupert addresses one of the most common myths pretty well. He says that accessibility is often viewed as making your website work on screen readers. But in reality, web accessibility is a subset of UX that's focused on making our websites usable by the widest range of people possible, including those who have disabilities. So when we're thinking about inclusivity on the web, it can be useful to break this issue down into smaller, maybe more digestible chunks. And in that same blog post, for instance, Dave breaks accessibility down into four different categories. There's visual, so blind or partially sighted users with obstructed vision, color blindness, or even just your aging parents. There's auditory, so users who are deaf or hard of hearing and could benefit from things like live captioning like we have on the screen today, or transcripts of audio material. There's motor and mobility, so those who find it physically difficult to use a mouse or keyboard and make use of some of the assistive technologies we just covered. And cognitive, so those who struggle with memory or understanding, perhaps because of dyslexia, autism, or other learning disabilities. And fortunately for us, there's a strong business case for accessibility. Studies show that accessible websites have better SEO and usability. They encourage positive coding practices and help us comply with any legal requirements regarding accessibility online. And the thing is that while people have realized these benefits for their products, it often ends there. Like, documentation is completely left out of the conversation. And this is a big problem, because if documentation is meant to serve as a tool for, learning, discovery, or comprehension, it has to be included in those conversations. One excuse I hear frequently when talking about this is that, well, documentation is for developers. Okay, this statement is problematic for many reasons, but let's start with this statistic. 1 out of every 200 software developers is blind or hard of sight. And this is probably the only time you'll see me, reference the Stack Overflow survey, for many reasons. But if we think about how narrow the participant set was for this survey, we can imagine that there are probably so many people who were not accounted for in this. People who are probably trying to read our documentation. Take Free Code Camp contributor Florian Byers. He was born blind, but he's able to code using a standard issue laptop. He wrote a blog post where he explained that inaccessible docs and tutorials were one of the biggest pain points for him while learning. He writes that the tutorials were undoubtedly good, but were completely unreadable for me. And then he goes on to explain some of the details of what the people who were writing that documentation might have missed. And as I mentioned before, I understand that accessibility is a lot to think about. But the reality is, most of us are already doing some form of accessibility, whether or not we realize it. Ensuring that the layout of our page is logical and follows standard conventions. Crafting user flows and learning journeys to fit a variety of use cases. Providing content in multiple languages. And testing that content between Chrome, Firefox, Safari, mobile, what have you. These are all forms of accessibility. We need to make sure that our products and the supporting documentation is accessible to all users, including users with needs that might differ from our own. And to put it bluntly, this is our responsibility as people who are writing the code, writing the documentation. Even if you're not the one writing the code, it's also your responsibility. Ann Gibson, an independent accessibility consultant, puts this really well. She says that we may or may not be responsible for writing the HTML, but if the developers we're working with don't produce semantic structure, then they're not actually representing the structures that we're building in our designs. So whether you're an engineer, designer, information architect, or maybe something in between, you have a hand in making your documentation accessible. But, how do we actually accomplish this? Let's start with structure and hierarchy. There's a good chance that you've heard that well-structured content is the best foundation for great documentation. Well, the same can be said for accessibility. A good question to ask could be, would someone be able to quickly scan this document and understand the material? Using subheadings to differentiate different sections or breaking down text into short logical chunks helps sighted users, sure, but it can also help anyone using a screen reader. But then we need to ask ourselves a separate question. Is the markup clean and structured? Laura Kalbach describes well-structured HTML as the secret weapon of great accessibility. And that's because when we write well-structured HTML without altering any of the default behaviors, our page becomes naturally accessible. Take these examples. We can use an H1 heading 1 tag to describe to our user what this page is about, or a nav tag to clearly indicate the start and end of our navigation bars. The aside tag can indicate when the content is secondary, like maybe a sidebar with some additional links. Or indicating whether or not we want a bulleted list, a UL, or an ordered list, OL. And fun fact, screen readers will usually actually read the numbers or say the word bullet at the beginning of each list item, even if those items have been hidden by CSS. One way that we can examine the page without even diving into the code is just by looking at the unstyled view. This is roughly the way that it would be read by a screen reader, from top to bottom. We can also supplement our HTML with ARIA. So ARIA is a web standard that is particularly useful when combined with a screen reader. And to understand why ARIA is important, we need to think about custom components. Things like drag and drop to upload content, or those little progress bars when you're watching a video or listening to audio. Those things are great, but they're really far from that default document-based behavior that browsers and markup languages were originally designed for. They need a little extra help, so that's where ARIA comes in. There are 3 main features defined in the ARIA spec: roles, properties, and attributes. ARIA roles define what an element is or does. The roles are used as a layer on top of the existing markup language for elements that don't have implicit roles. The ARIA role is also prioritized by the browser over an HTML tag. For example, if you use a div with role equals status, then a screen reader will read out that as a status rather than a div. ARIA properties define the properties of an element, which give them kind of extra meaning or maybe extra semantics. ARIA labeled by, for instance, allows you to put an ID on an element and then reference that as being the label for anything else on the page, including multiple elements, which is not possible when you're using traditional label tags. And finally, there are ARIA states, and they're a special property that define the current condition of an element. ARIA hidden is a really nice example of this, because if an element is only visible after some sort of user action, like maybe an error message, you can set ARIA hidden to true. And then once that element is present, you can then set ARIA hidden to false, so that it won't be read at the wrong time. And states differ from properties in the sense of properties don't change throughout the life cycle of an app. whereas states can change and are generally programmed through our JavaScript. But there's a time and place for ARIA. So for example, you wouldn't put the attribute like role equals navigation on a nav tag because it already has that semantic meaning. It should only be placed on things like div, span, or other kind of vague elements or elements where it's not implicit. So have you ever noticed those blue outlines that sometimes show up on links, inputs, or buttons? Well, those outlines are called focus indicators, and browsers by default use a CSS pseudo class to show these outlines on elements when they're selected. They might not be that beautiful, but these focus indicators let people know which element has the focus and helps them understand where they are on your website. The elements that should be focusable are links, form fields, widgets, buttons, and menu items. You can design focus indicators that fit the style or aesthetic of your brand or your site, and it goes well together. It's best to create a state that's like highly visible with good contrast so that it stands out from the rest of the content. And when you're testing your site, you can ask yourself questions like, can I tab through the page without getting lost? Do all focusable elements have that focus state? Can I operate tabs, accordions, search results? Can I exit a modal, like just using my keyboard? And do I have skip navigation link? And for those of you who are like, oh, what's a skip navigation link? Well, that's next. Skip links are an internal page link that are mainly used by screen reader users for bypassing or skipping over like repetitive web page content. They're not usually visible on a web page because sighted users can easily skip over content by scrolling down the page or just not looking at it. To show why skip links are necessary, let's take a look at Twilio as an example. I love Twilio dearly, and their docs are generally a great example of accessible documentation. But you'll notice that when we take away the linked style sheets, there are a lot of menu elements, and it takes a lot of time to get to the main content if you're using a screen reader. So adding skip links can help with this, and the Mozilla Developer Network web docs are a nice example. They include 3 separate skip links, one to skip to main content, one to select your language, and finally one to skip straight to search. Images. So these pose a problem because screen readers aren't sophisticated enough yet to interpret graphics on their own. So we need to provide that alternative text to help them out. And there are 2 ways to do this. We can add an alt attribute to our image element directly, or we can create that context within the surroundings of the image itself, or the text that supplements the image. And there are many great resources out there to write great alt text, so I'll just show you 2 nuances that I've kind of run into with this. So this is another site by Sarah Vieira called Is There Uber In?, which checks to see if there's Uber in a particular city that you're going to. You'll notice that there's this search by Angolia at the bottom, and that's actually an image. And up until recently, it didn't have any alt text. So let's see what the screen reader picks up.
Visited link image /91815484TF8B58060F5612F9852609.svg. Voiceover off.
So in case you missed that, this is what it read out. This is because it's kind of sweet. Like as an attempt to provide useful information, sometimes screen readers will read the file names instead of, if there's no alt text. But we don't always put that, we don't always think about that when we're, naming SVG files. So we want to make sure that our images are named appropriately just as a fallback. And if you're tempted to go to Sarah's repo and make a pull request to fix this, don't worry, someone already did. Open source is wonderful. We can also enable the screen reader to skip images that are either decoration or not necessary for comprehension, like the globe in the Is There Uber In? And we can do this by adding an alt attribute, but just leaving it blank. It'll just naturally skip over it. So charts and infographics go along with the image idea, and they're invaluable to documentation because they can present data in, sometimes a more clear visual way. And providing text alternatives to explain this visual content is usually the most straightforward way to making them accessible, but we don't want to just dump all of the words from an infographic into a paragraph or maybe spit out all of the data from a chart into our alt text. When you're crafting alt text for charts and infographics, we can ask ourselves, what are the highlights and lowlights of this graphic? And what are the most important and notable parts? I've also heard some people say that it helps if you imagine yourself trying to describe it on the phone, and just you don't want to explain the whole thing, just the main points. Another question we should ask is that if someone can't see colors, is the message still clear? Elements with more complex information, like charts and graphs, can be especially hard to read when you only use color to distinguish the data. So using other visual aspects to communicate this information, like shapes, labels, and size, works pretty well. You can also try maybe incorporating patterns to your fills and to make that difference just a little bit more visible. While it's not exactly an infographic, Trello has a colorblind mode, and it can provide really nice inspiration for adding text and patterns to your charts. If you want to check the contrast of something quickly, I use Color Oracle. It allows you to grayscale your screen pretty instantly, and there are also a couple other options for viewing your screen from the perspective of different types of color blindness. And if you're using text and want to make sure that the contrast is compliant with accessibility standards, you can use WebAIM's color contrast checker. In this screenshot, I was actually checking how the contrast of these slides would work. OK, so code snippets. They're very and understandably common in documentation. And it's totally possible to make them accessible for screen readers. We just need to understand what people are expecting to hear. So this is an example of an if block in JavaScript according to a cited user. We have if x equals true, console.log hello world. But this is how it would be read out by a screen reader. Some users will turn off notifications for parentheses and brackets, or maybe substitute left brace for lace. And while it may look kind of verbose to us who are sighted users, it is accessible, and it's possible to make them accessible. So to make our code snippets more accessible, we can follow that semantic HTML principles and use a code tag. And we can try to avoid using images or screenshots for code snippets, or at least images that don't have any alt text. We can avoid variable names that have no context, like foo, bar, baz, because it's easy to lose your perception while you're reading those or hearing them. And finally, I learned the hard way that if you have any trailing spaces, it will literally read out to you like space, 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 space. So good thing to watch out for. Along with our code snippets, charts, and other interactive documentation elements, we want to make sure that the words we're writing are readable and optimized for comprehension. Often what I see in documentation is that there will be these long, verbose chunks of text filled with bloated language. And by bloated language, I mean kind of overly complicated prose that are difficult to understand. Difficult to understand for anyone, but particularly for those who might have a learning disability or aren't reading in their native language. I've anonymized it a bit, but here's an example that's live on the internet. It says, this approach will work for our specific use case, but we haven't achieved the objective of truly encapsulating the behavior in a reusable way. Now, every time we want the tool positioned for a different use case, we have to create a new component, i.e. essentially another tool, that renders something specifically for that use case. That's a lot. and it's just 2 sentences. But it can be extremely difficult to read and comprehend on the first try, on any try. So we want to choose our language intentionally while we're writing. And using plain language is crucial for more inclusive documentation. Hemingway Editor is a tool that I use where you can paste your text into it, and it'll highlight problematic words and sentences for you, and also offer suggestions for how you can help it out a little bit. In this case, it defined the first sentence as hard to read in yellow, and the second sentence as very hard to read in red. It highlights unnecessary adverbs in blue and points out words that might have a simpler alternative in purple. And our sentence right now is a grade 12. And we want to get that down to a maximum of a grade 8 reading level. And don't worry about reading levels being, too low, because as the great Ashley Bischoff once said, no one has ever complained that something was too easy to read. And actually, if you want more tangible examples of plain language and accessible writing, I'd recommend checking out her talk from Frontiers. It is gold. All right. So now we've started optimizing some of our components. We want to write more accessible docs. But how can we actually test for accessibility, or maybe the lack thereof, in our websites? Once you get started in this kind of alley community, you'll hear the term WCAG often. And this stands for the Web Content Accessibility Guidelines. They're an internationally recognized adopted standards that were produced by the W3C to help us build a more accessible web. Any of the topics that we discussed today can be found in these guidelines, so you can always check against those. But there's a lot going on in the WCAG, and it doesn't necessarily help if, when we're trying to figure out what's wrong with our application, like we don't know and we're just trying to figure out how we can do better. Fortunately for us, though, most assistive technologies are free or inexpensive, or at least there are free or inexpensive alternatives. And this is great because it allows us to go directly to the source and experience the web in a similar way that our users might. And just in terms of screen readers, there are options like Apple products come with a screen reader built in called VoiceOver. You might have heard that's what I'm using in my demos. You can access it by pressing Command F5. And if it's your first time opening VoiceOver, you can listen to their Quick Start tutorial, and it'll give you kind of an interactive tour of VoiceOver navigation and interaction basics. Or there's NVDA, which is a free open source screen reader that you can use on Windows or a Mac as well. And whether you're using VoiceOver or NVDA, it's important to recognize that the way you or I might use a screen reader as kind of newbies is going to be really different than how someone who needs to use a screen reader to interact with the web, an expert, so to say, would use it. It's actually usually going to be a lot slower. If learning a screen reader is maybe too daunting or time-consuming and you want to get started right away, the developer tools on most modern browsers have started attempting to show hints or have accessibility tabs on how elements would be announced or interpreted by assistive technologies. There are also many free extensions and validators to help us automate accessibility testing and scan for errors within our site. Axe is an open source rules library for accessibility testing, and it was designed to enable developers to automate accessibility testing on their own instead of needing to bring in outside sources. It lives in the dev tools, and when you analyze the site, it'll come up with the issues, the number of occurrences, the element location, and even some suggested fixes. Or if you want something maybe a little bit more visual, Wave is a web accessibility evaluation tool developed by webaim.org. It provides visual feedback about the accessibility of the web content with little icons and indicators on the page. So for example, these are the Slack API docs, and when we click the web, when we activate web, it highlights these elements. In this case, it shows our navigation, our headers, it checks to see if we have alternative text on our images, and it also points out potential issues. In this case, it'll click on this one, and it says that we have a link text that might not make sense out of context. The bottom line is we need to start making accessibility a requirement and not just kind of an afterthought or a nice to have. But in order for this to happen, we need to think about how we can change our processes within our organizations and our workflows. So for instance, we can create and implement an accessibility policy. An accessibility policy can be anything from a formal document that's posted publicly to an internal set of tools and standards for your teams. Either way, it should be a statement that outlines your organization's intentions towards your product's accessibility. You might be familiar with this because this conference has an accessibility statement available on the website. And while DOF's statement focuses on the physical spaces of this venue, we can have something similar in our own documentation. Take Oracle, for example. Oracle has a dedicated documentation accessibility statement where it gives warnings about what screen readers might get wrong. For instance, the conventions for writing code require that we have closing braces and they should appear on an otherwise empty line. However, some screen readers might not always read a line of text that consists only of a brace or a bracket. And again, these statements don't always have to be made public, but posting them publicly shows your commitment to accessibility, and it also lets visitors know what they can expect from you. Many of the points I've mentioned in this can be added to development checklists, and that way you can check for these accessibility issues before it even gets pushed to production. And if you don't know where to start, the Alley project has a pretty thorough one that you can use, reference, or adapt for your projects. We can also browse the web from a different perspective. So maybe you can dedicate a whole day to browsing the web only using your keyboard, or spend an afternoon learning how to navigate a screen reader, or maybe turn your settings to grayscale for a week. Learning how to use assistive technologies ourselves is how we can build empathy towards users with needs that are different than our own. And finally, you can host an accessibility hackathon within your organization, or maybe more widespread if you're open source. There's a lot that you can accomplish in just a few hours or maybe days. Mozilla actually did this back in September, specifically for their documentation. And based on the blog post they published, which I've included on the slide, it seems like it was a great success. So while I've shared a lot with you the past 30-something minutes, this is really only scraping the surface of how we can integrate accessibility into our docs. Please feel free to find me over the next couple days or shout at me on Twitter, and we can explore this topic a bit further together. I'll also be sharing these slides on Twitter at carolstrand. But that wasn't the note that I wanted to end on. Rather, there was one thing that really stood out to me when I was researching. This is for everyone is listed as one of the design principles for the UK government. In it, they say, quote, "Everything we build should be as inclusive, legible, and readable as possible. If we have to sacrifice elegance, so be it. We're building for needs, not audiences. We're designing for the whole country, not just those who are used to using the web." And I believe that if we leave this conference and adopt a similar mindset, we can start creating documentation that is truly for everyone. Thank you.